Greetings and welcome back to the second episode of my devlog series. If you have accidentally stumbled upon this video, I recommend that you watch my first devlog where I explain what this series is before watching this video. This second episode will focus on the climbing system briefly introduced in my previous video and how I have improved it over the last 2 weeks. But before we can get to the bulk of this video, I need to tell you what led me to refactor large chunks of my movement-related code. As I started implementing basic stealth attack animations, I ran into quite a bit of trouble. When I click the attack button, my code checks whether or not an enemy is currently focused. This is determined by a specific variable. If it has a value other than null, or nothing, it specifies the enemy that's focused. If no enemy is focused, I currently just print a placeholder message to the screen. But if an enemy is focused, then a few location checks are performed to see where the player is standing in relation to the focused enemy. This is needed to determine the type of stealth attack that will be performed on the enemy. Sounds straightforward, right? Well, I omitted a few more aspects for simplicity's sake, but even if I had removed everything else from my code, there would have still been this error that would plague me for a few days. Whenever I stopped running the game, an extremely long error list would display with this identical error message repeated several hundred times. After I realized that this error was already kind of deep-rooted in the code like some errors in my movement system, I figured that a rework of my existing movement code was needed before I could start working on implementing new features. You see, my existing code was already getting quite complicated. At this point, my code was basically a house of cards waiting to be blown over by the slightest code change. Also, the single cards that made up said house of cards, the code snippets, couldn't really be reused anywhere else without the entire house collapsing. So I set out to refactor the majority of my hacky code. I'm still in the process of doing so, but over the last 2 weeks, I've already learned quite a lot and would like to share some of my current knowledge with you. Please note that this video is not meant as a tutorial. I will try to make a tutorial for creating and maintaining large chunks of code when I have figured out how to do so myself. Let me first introduce you to Unreal's blueprint coding system. It is the system I am currently developing Knitja with, as it's quite easy to use and understand. Blueprints work by connecting different kinds of nodes together in a graph. So here I am in the engine. I've prepared a basic example for you to showcase what blueprints can do and how you can work with them. Let me just play and show you what my example blueprint does. Let me just play and show you what my example blueprint does. Let me just click play. Let me just click play and show you what my example blueprint does. As you can see, it just spawns 5 random cubes in the world. If we now open up this object, you can see that this is all that I've created in here to create these 5 cubes in the level. It basically just spawns a cube at a random location in the world with a random rotation and a random scale that I've specified here, and then gives it the appearance of a cube. That's what this snippet of code does. And as you can see, it executes this whenever I start playing. As you can see, it executes this whenever I start playing. So it first spawns an actor. This is basically any object in the world with a specified transform. Then it gives it the appearance of a cube, and it moves on to the next one, and the next one, and the fourth one, and the last one. So this is all it really does. Now, as you may have noticed, these snippets of code are identical, aside from the values I insert here. So what I can do is I can create a function with some variable inputs, so I don't have to use up that much space of the blueprint graph, and I can more easily change my blueprint if I later want to. So to do this, I go to here, Functions, and click on this button to create a new function. And I can call it spawn cube at desired transform. There. Now, this function doesn't currently do anything. First, I need to copy this code in here and connect this, so it actually executes the logic here. Now, I don't want all cubes to spawn in the exact same location with the exact same rotation and the exact same scale. So what I can do is I can actually add a variable in here, and I call this cube transform, and I give it a specific type, the transform type. Now what I'm actually going to do is I'm going to recombine this and plug this into here. So now, if I go back to this graph and type in spawn cube at desired transform, I can call my function. But if we now compile this so it runs the new logic, and I press play, you see it actually didn't spawn anything. But it did. As you can see, it spawns a cube at the coordinates 0, 0, 0. And now, if I want to spawn my cube, let's say, here, I would just need to type these values in. Now, here's something that I'm not going to explain in great detail, but basically a transform combines the location, rotation, and scale into one variable. And I'm just going to type in the values, and that's it. Now I could do this for the other cubes as well and replace them with this function, but I'm not going to do that because I'm lazy and I'm just wanted to show you how you can simplify your own blueprint graphs if you want to. Blueprint graphs can get unclear rather quickly, so to keep them overseeable, you can put some functionality into a function, which also makes it reusable, as I just showcased. There is more to this system, but this is all you need to know in order to understand the rest of the video. As you can see, blueprints allow non-programmers to create gameplay systems without ever touching a line of code in an external development environment, like Visual Studio, for example. My work over the last few weeks was mainly to organize my code in different functions that make sense and to organize my variables. I continually added, changed and deleted functions and variables until I got a set of functions and variables that was actually doing what I wanted it to do, for the most part. This took many hours, but for once I felt like I had actually made a lot of progress in a relatively short amount of time. During the refactoring process, I had to fix many bugs that arose and realized the impact my hacky code had on the entire project's progress. So far, I have only kinda refactored the basic movement and climbing code. Yet, after 2 weeks of testing, bug fixing, creating, changing, and rearranging functions and variables, I am still not happy with the results. It was only at the end of the second week that I realized that my coding workflow hadn't changed a bit. I was still changing and adding code without doing proper planning beforehand. My code was only slightly better this time, because I now knew what the climbing system had to be capable of, and I could use my existing code as a starting point. So before I started writing this script, I went ahead and looked at a few dozen articles and videos that focused on writing clean code. I don't know why I only decided to do that after 2 weeks of struggling, but I either overestimated my coding abilities, or I was too proud to get help. Because of this, I won't be sharing the details of my current, and still flawed, codebase in this video. But one thing I'm going to share with you is how to create and use flowcharts. A few days before I started researching good coding practices, I came across flowcharts. Let me show you what my flowchart for the climbing system looks like. If it looks confusing at first, don't worry. Let me show you how you can create flowcharts on your own. Flowcharts can not just be used for programming, but also for planning processes and workflows in general. So to create my flowcharts, I used a free web tool called Code2Flow. It is still in beta, so some of the restrictions that will be enforced on free users aren't active yet, like the node limit, so use that to your advantage. So here I am in the currently empty flowchart editor, and I'll just quickly run through the different UI elements and tell you what they do, and then we will create a simple flowchart. So, first up, you can see this little editor window here. That's where you will be typing pseudocode. So as you can see, it directly affects what is displayed on the right side here, the actual flowchart. And then we have these different tabs. That's where you get to the home section of the site. And this is the edit section where you can actually edit your flowchart. This is the settings section. It mainly affects how the flowchart looks. You can play with it yourself and figure out things. It's not too complex really. And then we have this help section. So this is where you can find many different examples. And when you notice that when I click specific graphs here, it actually changes what's shown here. But don't worry, if you go back to edit, we have whatever we typed in here. It's still there, it's not deleted, so don't panic. And you can pretty much learn how to create a flowchart using pseudocode just by looking at the examples. So we have different sections here, all from the introduction, with just a simple overview flowchart, right to optional braces and everything in between. So now let's get back to creating our own simple flowchart. I'm just gonna go with the example of a daily routine. So our first node is going to be called Wake Up. So as you can see, it has created a round node with the text saying wake up. So now I can say brush teeth. That's the first thing we will do after we wake up. But as you can see now, it has put these two lines into the same node. If we don't want that, we can just add a semicolon. So now you can see that we have two nodes here, and they're connected by a little arrow. So first we wake up, and then we brush our teeth. That's basically what the flowchart is saying. So now we can add a condition, because the example, if teeth are dirty, we should brush them. So as you can see, it has now created this node with a diamond shape, and it says here, teeth are dirty, true, brush teeth. So now, if our teeth aren't dirty, then we can do something else. So now, as you can see, there have been branching paths, and as you can see, it says here, teeth are dirty, true, brush teeth, and teeth are dirty, false, do something else. So now you can also change that here, and as you can see, if I type in yes and no instead of true and false, it changes them here as well. But I'm just gonna leave them as a default. So now we can also add a switch statement. And what this statement does, it allows us to, it's similar to the if statement, but it doesn't just allow us to choose between true and false, but we can actually specify the different cases ourselves. So if we type in case, let's add something here first. So we can switch on different video games. So let's add a case for Super Mario 64. And if the video game here happens to be Super Mario 64, we can say collect stars. Now we can add another video game. Let's say Fallout 76. Fallout. So. And let's say quit playing, because I don't like this game. So as you can see now, it has created these two branching paths again, but they're not titled true and false. And they're also not controlled by these labels here. They're just called Super Mario 64 and Fallout 76, as we specified here. But now you can see, if we only want to play one video game, for example, then according to the graph, we will be playing Super Mario 64 and collecting stars, and then we will quit playing. But let's say we only want to play one game. We need to add a break in here, so it stops executing what's after the break. So now you can see we have this very simple example. And that's basically all I'm going to show you, because you can figure out most of this by just looking at the examples. For example, they have example for taking a bucket. Then we can switch on the bucket color. If it's a red bucket, we take red liquid. If it's a blue one, we take blue liquid. If it's a purple one, we leave the bucket empty. And that's pretty much it. So, this is going to be it for this episode. I will try to post devlogs more frequently in the future, but I currently have a lot of annoying real-life stuff going on, so I can't promise anything right now. However, finally, after a lot of time, I believe I am on the right track when it comes to writing clean code. Now this is the part of the video where I would instruct you to subscribe to my channel and follow me on other social networks. But I'm gonna skip that part. Now if you'll excuse me, I'm off to write great code.